back with another video on affine transformation, and in this video we are going to talk about composite transformations. So till now we have talked about what is a vector, we have talked about what is a translation, we have talked about reflections and rotations, we have talked about horizontal stretches, vertical stretches, enlargements and reductions. So if you haven't checked out the last few videos, then do check it now, right now, before moving on to this video. So what is a composite transformation? So composite transformation is when we do multiple transformations at the same time. That is, instead of doing it separately, let's say we were doing some rotations separately and some reflections separately, I am doing it together in a question, then that kind of a transformation is known as a composite transformation. So whenever I perform a linear transformation with a transformation matrix A, I get something like this AX. So I used to have a vector X. I am doing some kind of a transformation on X. With the help of a transformation matrix A, I am getting this. And I am doing a second transformation on this vector by multiplying it with B. So in the next step, I am getting B times AX. This is my X dash, this is my X dash. So what I can say that my X dash is actually B times A times X. Now don't forget, what is this B? This B is the second transformation matrix. What is this A? This A is the first transformation matrix. And togetherly, this B and A is what we called as a composite transformation. So let us understand this with the help of an example. So let's say, given this question, I have to find a single transformation that is equivalent to a reflection in the line y is equals to 1 upon root 3x and an anti-clockwise rotation about origin through minus pi by 6. So I have been given two different transformations. I have to combine them. I have to make a transformation matrix and I have to make a composite transformation matrix, and that is what I have to show, that what is my composite transformation matrix here looks like. Okay, so the first transformation that we do, by definition, we take that as A, and the second transformation that we do, we take that as B. So for finding out the matrix A, let us use the application we have learned so far. So I can see that for finding A, my reflection line looks like this, 1 upon root 3 times X. So I can say that over here, my tan alpha is equals to 1 by root 3. So using my calculator, I can say that alpha, which is my tan inverse of 1 by root 3, which becomes pi by 6. And then I need to find out 2 times alpha. That gives me alpha by 3. So for the transformation matrix over here, I need to find out cos 2 alpha and I need to find out sin 2 alpha. So cos 2 alpha will give me 1 by 2 and sin 2 alpha will give me root 3 by 2. So using this 2, I can construct my matrix A. So if you remember, whenever we were doing rotations, whenever we were doing reflections, the transformation matrix used to look like this. That is cos 2 alpha, sin 2 alpha, sin 2 alpha, and cos 2 alpha. That is with a negative sign. So over here, my matrix A will look like 1 by 2, root 3 by 2, root 3 by 2, and minus 1 by 2. So that's my matrix A. Let's try to find out matrix B. I need to find out an anti-clockwise rotation about origin through minus pi by 6. So whenever I am dealing with rotations, I have to be careful that the question should be mentioned in the form of anti-clockwise. And over here, it is mentioned in the form of anti-clockwise. So that's fine with me. So, yeah. So clearly over here, I can see that for a rotation, the value of my theta is equals to minus pi by 6. So if value of theta is equals to minus pi by 6, I need to find out what is cos theta and what is sin theta. So cos theta over here will become root 3 by 2 and sin theta over here will become minus 1 by 2. So the rotation matrix B we already know that it looks something like cos theta minus sine theta and cos theta. So putting the values here, I can say that my transformation matrix B over here is root 3 by 2, 1 by 2, minus 1 by 2, and root 3 by 2. So that's my matrix B. So that's my transformation matrix B. So the composite transformation matrix is B times A. So it is B times A. So over here B is root 3 by 2, 1 by 2, minus 1 by 2. Minus 1 by 2 and root 3 by 2. And what is my matrix A? My matrix A was 1 by 2 root 3 by 2. So it was 1 by 2 root 3 by 2 root 3 by 2 and minus 1 by 2. So after multiplying both of these, I am getting root 3 by 2, 1 by 2, 1 by 2 and minus root 3 by 2. So that's my composite matrix. That is the composition, that is the summation of two different transformation matrices. If I want to find out the nature of this matrix, let me do a further investigation. I can see that my composite matrix over here is in the form of A, B, B and minus A. And also, if I try to find out the determinant of this composite matrix, I am getting something as minus 1. So these two are the features of a reflection matrix. So what I can say that BA, which is a composite matrix, is indeed in itself a reflection matrix. BA is a reflection matrix. So that's the question on composite matrix. So I hope you have enjoyed and you have learned whatever we have gone through in this video. See you in the next one. Thank you so much, everyone.